Hello students, myself Dr. B. Sridhar, Professor, Department of ECE, MLR Institute of Technology, Hyderabad. Now we are going to discuss about types of optical fibers. Before that, we will see some list of content, definition of fiber optics, structure of optical fiber and the types of fibers. First of all, we should know what is the importance of fiber optics. So, in general, normal communication we are using the copper wire, but in fiber optic communication we are using the fiber. We are convert the electrical signal into light signal and we can transmit through the fiber. That's why we can call it's a fiber optic communication system. Now, here before that we should know what is meant by fiber optics. So, fiber optics is nothing but it's a cylindrical dielectric waveguide that transmits the light along its axis. Another important case is here you can achieve the total internal reflection. Why? Because whatever the signal we are propagating, so that signal can be reflected back to the core and can be transmitted. So, the total internal reflection is one of the important parameter in the fiber optic communication system. Generally, the fiber optic consists of a cladding layer and the core layer. After that, buffer coating also there. So, mainly we are concentrating more on the core and cladding. Now, we see the structure of the fiber. Now, here we have the core, cladding and the buffer coating. Okay. So, if you see here the N1 is the core refractive index and N2 is the cladding refractive index. Okay. Always the core refractive index is greater than cladding refractive index. So, then only we can achieve the total internal reflection. If we achieve the total internal reflection, our light signal will propagate without any loss. That is the important parameter. Okay. So, if we achieve the total internal reflection, then so here 100% efficiency we can achieve in the fiber optic system. Now, surrounded by the cladding we have the buffer coating. After that, some color coding also there, that is the outer jacket. Okay. So, it may be the single mode fiber or multi-mode fiber, some color coding also there. Okay. So, from the color itself we can identify whether the fiber may be the single mode or multi-mode. Fine. Now, let us see the types of optical fiber. Generally, the optical fiber can be categorized into three based on the material, based on the number of modes and based on the refractive index profile. Based on these three parameters, so we can categorize the optical fiber. Now, let us see based on the material. So, based on the material which you are using the fiber, can categorize say glass fiber or plastic fiber. Okay. So, here the glass fiber or a plastic fiber. Based on the material we are categorizing these two. Now, based on the number of modes, based on the signals are propagating, so we can differentiate a single mode fiber or multi-mode fiber. A single mode fiber only one signal can propagate, the multi-mode fiber any signal can propagate at a time, any single core. Okay. So, say a single mode and multi-mode fibers. So, next one based on the refractive index profile. So, we know the core has some refractive index, cladding has some refractive index. Based on the refractive index profile of the fiber, so we can categorize this step index fiber and graded index fiber. Okay. So, normally it can be categorized into three based on the material, modes and refractive index profile. Under this we have, under the material we have glass and plastic fibers. Under the number of modes we have single mode and multi-mode fibers, and under the refractive index profile we have step index and graded index fiber. Let us see one by one. We will see the glass fiber. So if the fiber is made up of a mixture of some metal oxide and silica glasses, then you can call it a glass fibers. So major thing is here metal oxides and some silicon materials. Okay, so if you use this kind of mixtures, okay, then it's called a glass fibers. Now you can see the plastic fiber. The plastic fibers, so which is made up of some plastic material, and also it's very cheap, very cheap. Another one major important thing in this plastic fiber, so we have high numerical aperture. So what is this numerical aperture? The numerical aperture is nothing but the light collecting capability, because so here we have the core. Okay, so here some light signal is propagating here. Okay, some light signal is propagating here. So here maximum light collecting capability is, we can call it a numerical aperture. Numerical aperture. Okay, so the quantum of the light information. Okay, whenever the numerical aperture is more, the information is high, the light collecting capacity. Also for plastic fiber, so we can handle it with low care, no issue, because it has the high durability and toughness. So these are the major advantages behind the plastic fibers. Now come to, based on the number of modes, we can categorize into two, as I said, single mode and multi-mode fibers. Okay, so first we will see about the single mode fibers. What is single mode? The mode is nothing but a single signal, a signal. Okay, a fiber, it's a small core which allows only the one mode of signal to propagate throughout the length. We call it a single mode fiber. It means, see, a single mode fiber, here my only one signal is propagating, because the core diameter in the range of only 5 to 10 micrometer, and the cladding is 125 micrometer, 100 to 125 micrometer ranges. Okay, so because of the small core, so here core radius, so we can transmit only a single signal, so we can call it a single mode fiber. The mode is nothing but a signal. Okay, fine. Now another one, multi-mode fibers. So multi-mode fibers, here these fibers which has a larger core, so which can accommodate many signal, many modes of lights. That's why you can call it a multi-mode fiber. Multi-mode fiber. Okay, so here the core diameter is high, so automatically here if you see the dimensions of the core is 50 to 200 micrometers. So it can able to accommodate the many modes of signal. So that's why you can call this a multi-mode fibers. So here let us see the cladding diameter is around 125 micrometer to 250 micrometer. So cladding diameter also plays a very important role in the multi-mode and single mode. Okay, so if the core diameter is vary, automatically the surrounded cladding also vary. Okay, fine. Now let us see difference between the single mode fibers and multi-mode fibers. As I said earlier, so here only one mode of signal is transmitted, here multiple modes are transmitted in multi-mode signal. Also here it has a small core diameter, this has a larger core diameter. Okay, so another important concept in the single mode and multi-mode fiber, here the difference between the core refractive index and cladding refractive index is small, but in multimode fiber, the difference between the core refractive index and cladding refractive index is high. This is one of the important difference between the single mode and multimode fibers. Another one, the numerical aperture is small in single mode fibers and numerical aperture is very large in multimode fibers. But even though it has a higher diameter of a core in multimode, but the high information carrying capacity is more in single mode fibers. But in multimode fiber, the low information carrying capacity. Okay, so this is one of the important point behind a single mode fiber and a multimode fiber. Another one, so single mode fiber which can use for only a short distance communications, but for multimode fiber we can use in long distance communication. For long distance, so generally we are using the multimode fibers only. Another one, dispersion. So this is a major drawback in the fiber optic system. Here the intermodal dispersion. So here only one signal is propagating, so there is no disturbance in the intermodal intersignal. Okay, so there is no intermodal dispersion in single mode fiber because only one signal is propagating. But in multimode fiber, so we are transmitting the multiple signal in a same core. So what will happen? So the intersignal interference can occur. So this is a major drawback in the multimode fiber. Next, here we know that the LED and laser are the two optical sources. So in single mode we are using the laser as an optical source, but in multimode we are using the LED as an optical source. And another one point is based on the construction. Fabrication is difficult and very costly come to the single mode fibers. But in multimode fiber, because of the core diameter is high, so manufacturing is very less difficult and also it's very cheap also. And come to the application point of view. So single mode fiber we can use in the submarine cable system, multimode fiber we can use in the telephone links. So these are the major differences between the single mode and multimode fibers. Now classification based on the refractive index profile. So the variation of the refractive index with respect to the radial distance. So the variation of the refractive index with respect to the radial distance from the axis of the fiber can call it the refractive index profile. So in this refractive index profile, in the sense, classification based on refractive index profile. The variation of refractive index with respect to radial distance from the axis of the fiber is known as refractive index profile. Based on the refractive index profile, we can categorize the fiber into step index fiber and grid index fiber. Let us see what is step index and grid index fibers. Now, you just see the diagram. See, the refractive index is uniform throughout the length. Okay, then you can call the step index fiber. The fiber in which the refractive index of the core is uniform. Some places it undergoes a sudden change at the core cladding interface. Let us see step index fiber. A fiber in which the refractive index of the core is uniform and which undergoes a sudden change in the core cladding interface is known as step index fiber. Now let us consider, so this is a core, so refractive index is N1, the surrounded the cladding refractive index is N2. Okay, So some sudden change in the refractive index of core cladding interface. So then what will happen? So my signal will sudden step index. You can call it a step index fiber. So because of the sudden change in the interface. So here also if you see, so step index single mode fiber. So if you see this diagram, this is step index single mode fiber. So here this is the core refractive index is N1, cladding refractive index is N2. So here we can mention the side view diagram. So if you see, this is N1 and this is N2. So this N of R is nothing but the radial distance. Okay, so actually we should maintain the same refractive index to entire length, but due to some sudden changes, then what will happen? The signal may be step up and down. Okay, so now this is single mode step index fiber. Now if you consider this is a single multi-mode step index fiber. What is multi-mode step index fiber means? Multi-mode means many signal will propagate, so that we know very well. Okay, multi-mode means many signal will propagate. This is the first one. Step index in the sense here a sudden change in the propagating path. Okay, here also same thing. Here the N1 is a core refractive index and N2 is a cladding refractive index. This N of R is nothing but the refractive index profile. Okay, let us see a gradient index fiber. You can call say gradient index fiber or gradient index fiber. So in this, the core has the refractive index that decreases continuously by increasing the distance of the fiber. So here we can consider, so this is a core refractive index is N1 and the cladding refractive index is N2. Okay, the refractive index profile has gradually decreased as the length of the fiber is increasing. So because of this nature, what will happen? So I am getting the smooth propagation of curve, smooth propagation. Okay, so we can call it say gradient index fiber. Okay, in step index here this abrupt change in the signal, but in gradient index because of the variation of the refractive index of the core, here I am getting the here a smoothened signal. So here also gradient index multi-mode signal. Here see, if you see the diagram, so here this is a N1 is a core and N2 is a cladding, this N of R is the radial distance. See this is a multiple mode signal. See here this RR in the smoothened structure. This is nothing but the gradient index fiber. Now we see a summary. So here first we discuss about what is fiber, the importance of fibers. Later we discuss about the structure of the optical fibers. The main structure of the fibers are core, cladding and buffer coating. And another one, the types of fiber. The fiber types based on material, based on number of modes, based on the refractive index profile. Based on the material we have the glass and plastic. Based on the number of mode we have single mode and multi-mode fibers, and based on the refractive index profile we have step index and gradient index. Thank you.